I had a request for problem number 16 on our second practice exam. This is a product rule problem that also includes a chain rule. So basically, hopefully you can see that this is the product of two functions. Negative x to the fifth minus 4 is the first factor, and then sine of 3x to the fourth is the second factor. Remember that when there's just one term, sometimes they leave off the parentheses, but they're implied. So this is actually the sine of 3x to the fourth. So we learned the product rule using placeholders u and v. And so when I set this up back in the old days, I would call this u, which is negative x to the fifth minus 4. And I would call this whole thing v, and we'd break up the product rule that way. So let me run through this. That's u equals negative x to the fifth minus 4. And the u prime then would be negative 5x to the fourth. And then we'd set v up as v equals sine of 3x to the fourth. Now I'm going to write this in a different color. Let's write this in yellow, because this is a composition, and we need the chain rule to get the derivative of this thing. I don't want to use the letter u like we do with our u substitution for the chain rule, because I've already used u in a different way for the product rule. So I'm just going to write it out with color what the derivative of this thing is. So this is v prime equals, the derivative of sine of u is just cosine of u. So I'll have cosine of 3x to the fourth. But then I have to multiply by the derivative of the u itself. So the derivative of 3x to the fourth, which is 12x cubed. And we usually write that factor out in front of the trig function. So the entire v prime is 12x cubed times cosine 3x to the fourth. Once you have that written out, you're ready to do your product rule to get y prime. That's our goal. So y prime is going to be v times u prime. So that's negative 5x to the fourth for the u prime, times sine of 3x to the fourth, plus u times v prime. So that's going to be, what do we have here? We've got negative x to the fifth, let me write this correctly, negative x to the fifth minus 4, that's the u, and then the v prime is 12x cubed cosine of 3x to the fourth. Now, on our practice exam, this is a multiple choice problem, and so they did a little simplifying in that problem. So I believe in terms of looking for the right choice, you're going to want to write your answer as follows. So we've got the negative 5x to the fourth sine of 3x to the fourth. We are going to distribute this whole term here to both of these in the parentheses. So I'm going to have negative, so minus 12x to the seventh, x to the eighth, because 5 plus 3 is 8, cosine of 3x to the fourth, and then another minus sign and a 48x cubed cosine of 3x to the fourth. And then in terms of the factoring, the only thing we can really do is we've got an x to the fourth here and an x to the eighth here and an x cubed here, is we can factor that out. So in the choices available to us, that's going to be what they did. They factored out an x cubed, and then they just wrote the rest of it down. I probably wouldn't simplify it this way if I were doing the problem. But that gives us a negative 5x sine of 3x to the fourth minus 12x to the fifth cosine 3x to the fourth. And then the last thing here is a minus 48 cosine 3x to the fourth, sorry. And that happens to be, on that particular problem, it was choice A. If you're keeping score at home on number 16, that was the choice for that problem. Excuse me, this isn't even number 16, this is number 15. So that tells you how much I'm paying attention. Let's fix this here so that the video looks right. This is number 15. Yeah. If I were more motivated, I would probably redo the video, but let's face it, it's late in the game. But I wanted to get out a quick explanation for how to do this problem. It's a product rule that has a chain rule in there. And then you have to do a little algebra to make your answer match the choices. So anyway, hopefully this helps, and good luck on the upcoming final exam. If you need me, you know where to find me. Take care.